Welcome back to our discussion of bonding at the pre-AP or 10th grade honors chemistry level. Now we're finally getting into Lewis dot structures. We talked about valence electrons and Lewis dot structures, and there are some differences in how teachers approach these, so don't get hung up if you watch another video and it's slightly different, but this is how I like to do it. I like to envision a square. So if we've got that tin, envision a square around the tin. Now, don't draw the square around the tin. Just envision the square around the element symbol. Okay, don't draw it or it gets too messy. All right, and then we start putting valence electrons around. And I like to do it according to Hund's rule. So Hund's rule says put them unpaired before you pair them. The tin has 4 valence electrons. I'm going to put them around the tin unpaired before I pair them. Right? Now, we want to do ions. Tin was one of the ones that ended in S2, P2. So if it lost its P2, that's what this is showing, we form the tin plus 2 ion. Notice we indicate that with a Roman numeral. We get a little bit into naming. We'll get to the fruition of naming in another unit, but we start it right now just to give you an indicator. We have to somehow tell you which ion we want, because tin can be plus 2 if it loses one of them, just the P sublevel, or it can be plus 4 if it loses both the P and the S's. So we have to tell you, and we do that with Roman numerals. Now notice once it becomes an ion, we write the ion charge, and I want you to pay close attention, not parentheses. You have to use those square brackets in order to correctly indicate a Lewis dot structure for ions. So let's go ahead and do these, and I want you to get into the habit of writing the atom first, doing the atom Lewis dot structure before you do the element. Lithium's group 1, so it has 1 valence electron. Now, it doesn't matter if you put that left, top, right, bottom. It doesn't matter, all right? Lithium is group 1. It wants to become plus 1, so it's going to lose that valence electron. If I lose it, I have no more dots, all right? And I have a plus charge. So we put brackets and a positive charge there. Let's take a look at boron. Boron is group 13. Boron has 3 valence electrons. So start putting them around as if it's a square, right? Now if I'm going to make the boron ion, now boron's a metalloid, but it's going to be primarily plus 3. So we're going to make the boron ion. If I lose those 3 electrons, then I'm going to make the boron ion. I have no more electrons. You put the number and then you put the sign of the charge. So I'd have boron 3 plus ion. Let's take a look at oxygen. Okay, oxygen has 6 valence electrons. So it doesn't matter where you start. 1, 2, 3, 4, 5, 6. So 2 of them end up being paired. Well, if you look at the group, that group wants to gain 2 electrons. To gain 2 electrons, and I should have done this up here. Let's change this instead of putting the charge. Let's put whether or not it lost. To become the lithium ion, it's going to lose 1 electron, so minus 1 electron, and this was minus 3 electrons. I think that's more helpful. Okay, so now for oxygen, it's plus 2 electrons. You add electrons, you're becoming more negative. So 1, 2, 3, 4, 5, 6, 7, 8. I gained 2 electrons. So maybe if I put those in a different color, you'll see them more clearly. Do you see I gained an electron there and I gained an electron there? And when you gain electrons, it becomes more negative. So I call that 2 negative. And now let's look at bismuth. Bismuth has 5 valence electrons. 1, 2, 3, 4, 5. Now, this particularly says the bismuth plus 3. To become less negative, I'm going to lose electrons. So I'm going to lose 3 of those dots. And I'm going to make sure I take away the one that was paired, so that'll minimize repulsion. So if I lose 3 dots, I think I have too many dots. I'm going to erase one there. I have 2 dots left, so that's the 3 plus ion. I'm just going to do a couple more, and then we're going to move into making ionic bonds. And phosphorus has 5 valence electrons. 1, 2, 3, 4, 5. Now I'm going to make the phosphide ion. Ide means make the negative ion. We're going to make it a negative ion by giving it 3 electrons. So it did have 1, 2, 3, 4, 5. Remember, the octet rule says that it wants 8. So I'm going to give it 3 electrons. 1, 2, 3. Ide means make the negative ion of, and so 3 negative ion. Okay. Now, let's take a look at these next 2 down in the bottom. Xenon and helium. They don't make ions. So I'm not showing the ions of these. Instead, let's just show you the Lewis dot. Group 18 has 8. I should have done those individually. Group 18 has 8, but except helium. Be really careful. Helium only has 2 electrons. You can't just mindlessly go by the group number there. You have to think about how many electrons it has. Has 2 electrons, it will lose 2 electrons. Now, let's take a look at, and this might be a longer video than you're used to, but we're just going to keep going. All right, let's take a look then at making ionic compounds. Remember, I said our goal is to have a neutral formula unit. So what we want to do is we want to first draw the ions. So sodium, go ahead and draw sodium here, has 1 valence electron. It's a metal. It's going to lose that valence electron and become this sodium plus 1 ion. Chloride, on the other hand, has 7 electrons. 1, 2, 3, 4, 5, 6, 7. It wants to gain that electron. So when it does, metals are losers, nonmetals are winners to get to the octet. I'm going to have 8 electrons here. Now, if I look at this, plus 1 minus 1 is neutral. So to give you a glimpse of the future, I wrote 1 sodium and I wrote 1 chloride in order to get to a neutral formula unit. That's our goal, is a neutral formula unit. Let's look at calcium fluoride here. So calcium is group 2, so it has 2 valence electrons. Okay, metals are losers. It's going to lose that. Sorry, that bracket didn't turn out real well. It's going to lose it. If you lose 2 electrons, it becomes a 2 plus ion. Okay, fluoride, ide means make the negative ion of. It's like chlorine. It has 7 valence electrons, and so it wants to take those. But it can only take 1. It can't take both of them. Whoops. Hopefully it won't die on me while I'm still in my video here. Maybe that's my hint to hurry up. So if it gains, that's what I'll get. It'll become more negative. It'll be negative 1. Well, now I have excess positive. So if you have excess positive, give it a negative. So let's give it another negative. And make sure you alternate positive and negative charges. I'm going to show you the algebra way to do this in class. But for now, just go back and forth. And so I've got 1 calcium. And to to indicate that I did 2 fluorides, I'm going to put a 2 down here. And that says I added 2 fluorides. All right. So now let's do the aluminum. This is a little trickier, but it's the last one. So let's take a look at it. Aluminum oxide. Let's first draw our aluminum. So I'm going to go ahead and do it down here since I have the room. Aluminum has 3 valence electrons. Okay, and metals are losers. It's going to lose all of those. So I'm going to have the aluminum plus 3. Now, oxide, "ide" means make the negative ion of, has 6 valence electrons. Nonmetals are winners, and I'm just going to draw, let's just draw one right here, down below. As long as you alternate, I don't care how you do it. So it's going to gain 2 electrons. Oh my gosh. It's going to gain 2 electrons, and it'll be like this, 2 negative. Now we've got 2 negatives and 2 positives, so we have excess positive. So let's draw another negative. And so we draw another oxide with its 2 negative charge. Now we have 4 negatives and 3 positives. It's still not neutral. We have excess negative, so let's draw another positive. I'll put it in different color here. So we've got to draw another aluminum because we had excess negative. So let's draw an excess positive there. It's still not neutral. I have 6 positives and I have 4 negatives. I have excess positive. So let's draw another negative. And as long as you simply alternate, I don't care where you put them. So we're going to put another oxide in here. There's my lovely square. There we go. All right, now if you could actually read my writing here, you would see that I have 6 positives and I have 6 negatives. It's neutral. And to make it neutral, I had to write 2 aluminums and I had to write 3 oxide ions. Okay, that's it for now. Talk to you later. Bye-bye.